I didn't have access to any paper larger than printer paper at my house, so I decided to recreate this project using a Google Slides page. I set the page to be a custom size of 100 inches by 100 inches to make sure that I could fit everything. And I'm going to walk you through the different reservoirs of carbon, uh, zooming out when necessary. I'll go from smallest to largest. So we're going to start with the atmosphere, which is represented by this blue circle. That circle has a radius of 11.6 millimeters, which gives it an area of 426 millimeters squared. And as the conversion of 1 millimeter squared equals 2 gigatons of carbon, that means this reservoir has 852 gigatons of carbon. We're going to scroll up to the vegetation and soils radius, and that gives you an idea of about how much bigger the circle looks like. The vegetation and soils has a radius of 24.6 millimeters. This reservoir has an area of 1,900 millimeters squared, which gives this reservoir a 3,800 gigatons of carbon mass. So that's our vegetation and soils reservoir. Moving up, we'll go to fossil fuels that are still unburnt. These are relatively similar in size for their reservoirs. This is a radius of 26.2 millimeters, which gives it an area of 2,150 millimeters squared and a mass of 4,300 gigatons of carbon. Next, we move up and we get a much larger reservoir here of the oceans. Oceans has a radius of 77.8 millimeters, which gives it an area of 19,000 millimeters squared and a mass of 38,000 gigatons of carbon. From here, we have to do some zooming because the objects get much, much larger. The brown circle here represents the crust. It has a radius of 952.5 millimeters, which gives it an area of 2,850,000 millimeters squared and a mass of 5.7 billion gigatons of carbon for the reservoir of and the crust for the carbon reservoir in our crust. And even larger still is the reservoir in the mantle, which is represented by the red circle here. The red circle barely fits within my sheet. The mantle has a radius of 1,261.6, little typo there, millimeters, has an area of 5 million millimeters squared, which gives it a mass of 10 billion gigatons of carbon. And you can see at this scale, the atmosphere reservoir is hardly visible. So it is much, much, much larger reservoir when we're talking about the mantle and the crust than any of the other reservoirs on Earth. This is my project. Sorry for not doing it on paper, but hopefully this will work just as well.